Out there, in the gigantic absence of clearness of room, the James Webb Space Telescope has been examining the littlest things for replies about the universe. This NASA's new eye above has been tracking down stunning pictures of stars, tremendous planets, and planets. Finally, something disturbing has been found. Something so colossal it could shake the genuine spines of all that we grasp. It has researchers scratching their heads and investigating whether it could light the farthest fundamental of everything. Go close by us as we inspect how the most recent discoveries of the James Webb Space Telescope could crush our comprehension of the universe. When we investigate the edge of the universe, we are discussing the recognizable universe. The perceptible universe radiates an impression of being a window through which we can take a gander at the degree beyond the recognizable universe. It incorporates all that we can right now see, measure, and examine utilizing our telescopes and space tests. It's a plan of stars, frameworks, and cosmic bodies within our grip of finding. Anyway, the noticeable universe is only a bit of piece of the whole universe. Imagine it as a cut from a gigantic pie that we're prepared to study and handle. While the complete size and state of the universe overall stay a secret, researchers gauge the width of our recognizable air pocket to be around 93 billion light-years. A light-year measures the distance that light, the quickest thing in the world, goes in 1 year around 5.88 trillion miles or 9.46 trillion kilometers. So when we discuss the expansiveness of the detectable universe being 93 billion light-years, we're examining a giant stretch. Around 13.8 billion years ago, the universe burst into reality in an incredibly strong effect. This event began what we call the Big Bang. Since that giant birth, the universe hasn't basically been fostering. It's been advancing quickly in its development. Frustrating forces, like the strange dark energy, which seem to be driving the speed increase, have been further isolating the limits of the universe as the universe loosened up. Matter began to gather, influenced by gravity. This gravitational power joined particles, birthing shocking plans. Stars, giant frameworks, and ultimately planets like our own Earth. Picture the universe passing by as these gigantic structures illustrated, framing into the exceptional yet continually advancing eccentricities we see across the universe today. Regardless of what its enormous size, the universe is unquestionably void. If we somehow wind up pulling back our whole planet, gathering to the size of a quarter, the closest star would still be about the length of 2 soccer fields away. This limitless quality enlarges right inside our own Milky Way galaxy, which is only one among billions in the apparent universe. This gives us a sense of the sheer size of unfathomable space. Now, you could inquire as to why we can't simply see all that exists in the universe. There are a few explanations for this limit, mostly involving light. The fastest thing known to man still gets a chance to go through space. This proposes that when we take a gander at far-off objects, we are essentially zeroing in on the past. The farther an item is, the more time its light has taken to contact us. It's like glancing through a giant time machine, unrolling the history of our universe. As we notice frameworks millions or even billions of light-years away, the universe is widening. Imagine spots on the outer layer of a creating inflatable. As the inflatable expands, the spots move farther apart. This same rule applies to the universe. Galaxies, like those spots, are floating apart as the outer layer of space extends. This extension causes the light from a long way off objects to go through a shift known as redshift. Basically, the frequencies of light stretch as the items move away, pushing toward longer frequencies, normally giving off an impression of being bronzed in variety. Given these variables, light's development time, the extension of room, and the universe's reliable augmentation, it's not amazing that we haven't yet totally seen all that the universe offers. Even with our especially high-level telescopes and technology, our view is still limited by these fundamental properties of the universe. The journey to grasp the conceivable edge or limits of the universe has enthralled the minds of huge people across disciplines. While undeniable responses remain perilous, 3 conspicuous hypotheses have arisen, each offering interesting points of view on the expansion of endless space. The first hypothesis proposes that the universe develops gigantically, continuing perpetually without a discernible edge. This thought lines up with the cosmological standard, which states the isotropy of the universe, that it appears to be consistent from any vantage point. Assuming the standard holds, it suggests that the universe comes up short on limit and expands unfathomably toward each bearing. The second hypothesis offers an elective view, suggesting that while the universe may indeed be limited, it comes up short on a clear edge. Maybe it could look like a gigantic circle or a wound space like Earth. In this situation, if one somehow managed to travel unendingly toward any direction, they would ultimately get back to their starting point, like circumnavigating Earth. The third hypothesis, the multiverse theory, presents an interesting thought, that our universe is only one of innumerable others. Imagine a boundless number of parallel universes, each existing with its own set of physical regulations, constants, and properties. These universes might be very different from each other, working independently, or they might be interconnected through complex systems, forming a gigantic and confounding multiverse. The James Webb Space Telescope, JWST, remains as a badge of potential, illuminating the secrets that lie at the gigantic starting points of the universe. This unbelievable instrument has an unparalleled ability to relax the jumbling past of our universe, permitting us to peer far beyond what was previously conceivable. The JWST is a mechanical wonder, designed explicitly to observe the universe with striking precision. Its high-level capacities stretch our vision to the earliest moments of the universe. A critical study published in the renowned journal Nature revealed the JWST's discovery of 6 massive galaxies, dating back between 500 million and 700 million years after the Big Bang. Incredibly, these old galaxies are far bigger than anticipated for their early presence, testing prevailing theories of universe formation. Moreover, their development in the early universe is truly astounding. What's outstanding about these discoveries is the degree of complexity in these ancient systems. This goes against the assumption that galaxies form slowly over time. These enormous galaxies show a level of complexity equivalent to our 13-billion-year-old Milky Way galaxy. The sheer number of stars inside these titanic behemoths surpasses our expectations, with each galaxy boasting a total mass several times greater than our Sun. Strikingly, one of these galaxies may even have a mass up to several times that of our Sun, eclipsing the already gigantic size of our Milky Way. The JWST's unmatched ability to explore the universe's mysterious spaces relies on its use of infrared light, an invisible range to the naked eye. This astounding power enables the telescope to capture the weak emissions from ancient stars and galaxies, revealing huge remnants that have persevered for billions of years. Essentially, the JWST acts as a time machine, moving our vision back through the ages and offering a captivating look at the universe as it appeared nearly 13.5 billion years ago. The consistent discovery of massive galaxies, rigidly nicknamed universe breakers, has changed our understanding. It's like revising history, a staggering twist that challenges many of the models we had laid out for early galaxies. Initially, we believed galaxies formed from humble beginnings, starting as small collections of stars and dust. They were thought to grow slowly over time, increasing in size and complexity. However, the universe breakers have shattered these ideas. When the JWST data and its high-resolution images revealed these massive structures, these colossal behemoths appeared seemingly out of nowhere, as if they had just been discovered, astonishing our past understanding of cosmic development. Digging deeper, experts used spectroscopic techniques to analyze light across different frequencies. This examination holds the key to unlocking critical insights about these mysterious galaxies, such as their structure, size, and distance from Earth. It's like an immense investigative story, with light as the key to uncovering the mysteries of these gigantic entities. The astounding revelations from the James Webb Space Telescope have transformed our understanding of the universe to remarkable levels. This cutting-edge telescope, operated by a global team of space researchers, has recently uncovered a stunning discovery: the identification of the oldest and most distant galaxies ever observed. These galaxies transport us back to when the universe was only a tiny fraction of its ongoing age, existing just a short time after the Big Bang. The James Webb Space Telescope, out in the immense darkness of space, has been searching for answers about the universe. It's NASA's latest powerful instrument, capturing stunning pictures of stars, galaxies, and planets. Recently, it made a discovery so awesome that it could change how we understand the very fabric of the universe, leaving specialists shocked and curious about its true potential implications. When we study the universe, we begin with the visible universe, a window into the infinity beyond. This visible universe includes everything we can currently interact with through our telescopes and space probes, including stars, planets, and other celestial bodies. However, it's just a small part of the whole universe. Researchers estimate the width of our observable universe to be around 93 billion light-years. A light-year measures the distance light travels in 1 year, around 588 trillion miles, making the range almost infinite. Around 13.8 billion years ago, the universe began with the Big Bang, a massive explosion that triggered the Great Expansion. Since then, the universe has been growing and speeding up, driven by mysterious forces like dark energy. Matter began to combine under gravity, forming stars, galaxies, and eventually planets like Earth. This ongoing process shapes the universe's vast size, allowing us to observe only a small piece of its endless complexity. Indeed, even with this expansion, much of the universe remains dark and empty. No matter how far we've come in exploring space, most of it remains hidden. Even with the power of the James Webb Space Telescope, vast portions of the universe remain distant. Yet its discoveries continue to reshape our perception, offering a glimpse into the amazing wonders that lie just beyond our sight. The immensity of space continues to astonish and inspire. However, with each remarkable observation, we are slowly piecing together an increasingly intricate understanding of the universe's history and future. The James Webb Space Telescope is a tool that could forever alter the way we think about space, time, and the very nature of our reality. The repercussions of the JWST's discoveries extend beyond mere academic observations. They challenge the very foundation of modern cosmology. If these titanic galaxies existed so early in the universe's history, it drives us to rethink current models of galaxy development. For years, scientists have adhered to the idea that galaxies grow slowly, starting as small, dense collections of gas and dust, gradually evolving over billions of years. The discovery of these massive galaxies, formed within the first few 100 million years after the Big Bang, presents a mystery that doesn't align with this slow progression. This revelation raises new questions about the nature of galaxy formation itself. How did such large, complex galaxies form so quickly after the universe's inception? What forces were at play during those early times that enabled rapid star formation and the development of galaxies on a massive scale? These questions don't just challenge our current understanding of the early universe. They also stretch the boundaries of our knowledge of physics, especially regarding the behavior of dark matter and dark energy during the universe's infancy.